This video is the 10th video in the complex number set of videos, and in this video we're going to look at equality of complex numbers. Now, if two complex numbers are equal, their real parts must be the same and their imaginary parts must also be the same. So in other words, if we have two complex numbers in which one is a plus bi and the other is c plus di, and those complex numbers are equal, well then a would have to be equal to c, as the real parts would have to be equal to each other, and b would have to be equal to d, as the imaginary parts would have to be equal to each other. We can use this fact when solving particular questions. This is best explained by going through a few examples. Example 10.1 says if 3x plus 4yi is equal to 16 plus 6i, find the values of x plus y. To find the values of x plus y, it's best to equate the real parts and equate the imaginary parts. Before I do this, I highlight my real parts in one colour and highlight my imaginary parts in another colour. The real parts here, we have 3x and 16, and the imaginary parts, we have 4y and 16i. Equating those, well, 3x is going to have to equal to 16, and 4yi is going to have to be equal to 16i. To figure out what x is, well, it's just going to be 16 divided by 3. And to figure out what y is, first of all, I'm going to eliminate the I from both sides, and I'll be left with 4y is equal to 16. I'm going to divide both sides by 4, and I'll be left with y is equal to 4. Example 10.2 says find the values of x and y if x multiplied by 2 plus 3i minus 2y is equal to 4 plus 9i. Here, before I equate any parts, I'm going to have to multiply out the bracket. So I'm going to multiply the x by the 2 and the x by the 3i. When I do that, I'll be left with 2x plus 3xi minus 2y is equal to 4 plus 9i. Now I'm going to highlight the terms that have i's in them and the terms that have no i's in them. So we have 2x minus 2y and 4. They don't have any i's in them. And then we have 3xi and 9i. Equating them, we get 2x minus 2y is equal to 4. And 3xi is equal to 9i. Looking at the imaginary part first of all, well, there's an I in both, so we can eliminate the I. Then we'll be left with 3x is equal to 9, so divide that by 3, and we'll get that x is equal to 3. As we now know x is equal to 3, I can bring that value and replace it for x in the equation up here. That means we'll end up with 2 times 3 minus 2y is equal to 4. 2 times 3 will give us 6, and we'll be left with 6 minus 2y is equal to 4. Minusing 6 from both sides, we'll be left with 2y, or minus 2y is equal to minus 2, and then dividing both sides by negative 2, we'll end up with y equaling 1. Therefore, the values of x and y in this question is x equal to 3 and y is equal to 1. In example 10.3, it says find x and y if 3x plus 2y plus x plus 4yi is equal to 7 minus I. Here, they've already grouped the real and imaginary parts. We have the real parts here, and that's going to be equal to 7. We have the imaginary parts here, and that's going to be equal to 1. Doing that then, we'll be left with 3x plus 2y is equal to 7. And we'll have x plus 4y is equal to minus 1. Hopefully you can spot here that we have simultaneous equations. What I'm going to do to make this simultaneous equation cancel out is I'm going to multiply the top line here by minus 2 so that we can cancel out the y's. When we multiply the top line by minus 2, we'll get minus 6x minus 4y is equal to minus 14. And the bottom line we're going to keep the same. So we'll have x plus 4y is equal to minus 1. Solving simultaneous equations then, we have minus 4y and plus 4y. So the number in front of y is the same, but the signs are different. When we have that, we underline the two lines together and we add the lines. So we have minus 6x plus x, which is minus 5x. Minus 4y plus 4y will give us 0. And we have minus 14 minus 1, which is minus 15. Dividing both sides by minus 5 then, we'll end up with x is equal to 3. Because we know x is equal to 3, we can take one of the equations, either one, it doesn't matter. I'm going to take the x plus 4y is equal to minus 1, and I'll replace the x with what I know it is now, which is 3, and I'll get 3 plus 4y is equal to minus 1. I'll minus 3 from both sides, and I'll end up with 4y is equal to minus 4. Divide both sides by 4, and I'll get that y is equal to minus 1. Making sure we've answered the questions, we found that x is 3 and y is minus 1, so we've found what x and y are. Example 10.4 says solve for x and y in x multiplied by 1 plus 2y plus y multiplied by 2 plus 3i is equal to 8 minus 14i. What I'm going to do here is multiply out the bracket, so I'll multiply the x into the 1 and into the 2i, the y into the 2 and the y into the 3i. That will leave me with x plus 2xi plus 2y plus 3yi, and that's equal to 8 minus 14i. I'll then equate the real parts and the imaginary parts. X is real, 2y is real, and 8 is real, and then 2xi, 3yi, and minus 14i are imaginary. So I'll get that x plus 2y is equal to 8, and 2x plus 3y is equal to minus 14. And I'm leaving out the imaginary parts there as each of them have an I, meaning we can divide across by I, meaning we don't really need to write it. What I'm going to do then is I'm going to multiply the top line by -2 so that the x's will have the same value and different signs. When I multiply the top line by 2, I'll end up with minus 2x minus 4y is equal to minus 16. The bottom line will stay the same, so we'll have 2x plus 3y is equal to minus 14. Now you can see that I have 2x and minus 2x, where the number in front of x is exactly the same, but the signs are different. So when that is the case, I'm going to underline my two lines and I'm going to add the lines together. We have minus 2x and plus 2x, which give us 0, minus 4y plus 3y, which gives us minus 1y, and then minus 16 minus 14, which gives us minus 30. And if minus y is equal to minus 30, y will be equal to 30. Then I'm going to take the equations that I had at the start. So here I had x plus 2y is equal to 8. I now know that y is equal to 30, so this becomes x plus 2 times 30 is equal to 8. So I'll be left with x plus 60 is equal to 8. I'm going to minus 60 from both sides, and we'll be left with x is equal to 8 minus 60, which will give us minus 52. Therefore, if x times 1 plus 2i plus y times 2 plus 3i is equal to 8 minus 14i, then x has to be minus 52 and y has to be 30. That brings us to the end of this video, which is based on equating complex numbers.